In the last section, we talked about the ideas of continuity and what it really meant for a function to be continuous. And in this short secondary section, we're going to take a look at a very, very important consequence of continuous functions in what we call the intermediate value theorem. Now, this is going to be one of many different theorems in Calc 1 that are of really, really high importance and that we'll use very, very often. So first, to understand a little bit about what this theorem is going to address, let's take a look at this starting question. Suppose that I have a function f, and it's a continuous function everywhere, okay? So just suppose it's continuous everywhere. It's always connected. No holes, no jumps, no gaps, no breaks, okay? And suppose that what we know is that f of 3 is equal to -4. So I know there's one point on the function, right? When I plug 3 in, I get -4. And also, when I plug 10 in for x, I get 2 back for y. Now, I don't know anything else about the function except that it's all connected. I don't know if it's a linear function or a quadratic function. It could be none of those. It could be like a horrible piecewise function. I have no idea. But here's a question. Must this function have a 0? That is there an x value so that I can plug an x into the function and get 0 back? If you almost kind of think about it, we'd be dealing with a scenario something kind of like the following. I know that when I plug in the value of 3, I get back the value of, say, -4. 3, -4. And when I plug in the value of 10, I get back the value of 2. So maybe this is the picture. Does there have to be a spot on here where this function has to hit the y value of 0? Well, as I state here in the note, the key is to really think about what the graph of this question would look like, which is why I started to sketch this picture. And if you think about what we said in the last section, you'll realize an important idea. If I try to sketch this function, if I actually try to go ahead and sketch this out, that is, I know that I have a continuous function, so I know I'm going to have to connect the dots of 3, -4, and 10, 2. I'm going to have to connect those without picking my pencil up off the page. Then most certainly, at some point, I'm going to have to cross that x-axis, which has y value 0. So if you take a look at this, you can see that this is what the intermediate value theorem is really all about. Suppose that f is a continuous function on a closed interval, maybe from like 3 to 10. If n is any y value that's between two y values on the function, as long as those y values are not the same, then there exists a number c in a to b such that f of c equals n. Oh gosh. Okay. You kind of got to hate reading these theorems sometimes because they're really confusing. All right, we're going to try to link this theorem again back to this picture, and I'm going to try to do it by drawing out down here a more general version of the picture that we had up above. So let's go ahead and actually try to sketch this out really, really carefully. Okay, so what I'm going to have here, again, is kind of like a basic starting point that I did before. Let's suppose that I had 2 points, A and B, on my x-axis. Kind of feel like I had 3 and 10. And those are going to correspond to some points on my picture. So maybe here I have 2 points and they're up here. So this point would be A, comma, well, I guess f of A. And over here I would get B, comma, f of B. And I don't know how these points connect, except that my function is continuous. Now, as long as n is some y value that's in between these two, whether that's y value 5, y value 0, y value 10, it doesn't matter. But if there's some y value I want to hit, just like up here, there was a y value that I was interested in hitting, it was y equals 0, then I know that there's going to be a time, if this is a continuous function, where I'm going to end up crossing that. And that is going to occur at a value that we will call C. So there is a value C. Notice it's going to be in the interval a to b. It's between the two starting points. And I know that when I plug C into my blue function, what I spit back is the value of n. All right, this is still pretty intense. There's a lot going on here. But I'm going to encourage you to try to remember a lot of our important theorems in this class by kind of remembering their associated picture. The general idea of the intermediate value theorem is that it allows us to see when a continuous function, or allows us to see that a continuous function will cross over a specific y value.